everybody, this is Todd Frazee, and this is the tutorial for the TCOSE-03-CAD project. For this project, you're going to need the drawing. As shown, you're going to need sheet 2, and we're going to be modeling the 03 part. It is a sheet metal part, and what's interesting about this one, it's the only one on the drawing that has a flat pattern. So some of our dimensions need to be derived from the flat pattern and some of them from the bent sheet metal profile. We're going to start off by drawing a sketch that follows the side profile where you see my cursor, and we'll be using those dimensions. This flange here at the bottom, we also have to derive at its width. So we have in the flat pattern, we have 15, we have 5, and then we have 66. But we have a distance from the shelf here to the top of the other shelf is 60. Another issue is there isn't a dimension going to where the corner is on this side cut. There is a dimension that's 36 millimeters that goes to the hole, 8mm hole, and it does appear to line up with where the angle changes. So we're going to use the 36 millimeters and assume that that dimension applies to the corner as well. All right, let's go to Fusion. First thing we're going to do is we're going to open a new file, and then we're going to switch our settings to millimeters, and if they aren't already. And OK. Now we're going to save our part. We're going to call this TCOSE and your first 03, and then your first initial, last name, like all our projects. Hit save. Now we're going to create our sketch. Now because this primary sketch that we're doing is in the side view, we're going to actually sketch on the right side plane as well. We're going to start off and we're going to draw our S profile. Doesn't have to be perfect, but we do want it to anchor on the origin. Okay, so we have this Z shape, resembles the part. We want to make sure that the blue line that's highlighted is vertically constrained and constrained to the origin. We're missing a line. One more line there. And now we're going to put on our horizontal dimensions. So this first leg here, the longest leg is 6 millimeters, and this foot at the bottom is 5. We're going to hit finish sketch. And now we have the sketch ready to make a base flange. To make the base flange, we need to first start out by setting our sheet metal rules. So you're going to go to the icon here under sheet metal, go to sheet metal rules. We're going to select aluminum, millimeters, and select on the edit rule icon, which is a little pencil shape. Our thickness should be 1 millimeter, K factor of 0.44. The next box should be thickness. Under bin conditions, you're going to change it to 0.01. We can leave the relief information alone at default. You perhaps may have thickness where I have highlighted under relief width. That's fine for this part. And it's going to use these parameters to thicken this sketch. Okay, if you've made any changes, hit save. And then we're going to pick on the flange tool. And a little box will pop up and just select your sketch. And there's a series of parameters we set here. The distance, it's the distance we're going to extrude the sheet metal part. So according to our print, that's 50 millimeters. And then we need to look at our line and compare it to the dimensions we used and see did it offset to the correct side of the line? And in my case, it did not. I wanted it to offset to the left and down. So I'm going to select side 2, and it shifts the side the sheet metal is offset on of the curve. We're going to one side, we're making a new body, make sure you have aluminum millimeters selected, and then we'll hit OK. We can rotate to a 3D view now and see that we have a sheet metal bent part. Now to do some more modeling, we're going to actually flatten this part. But before that, I want to put in some of the features that we would have in the part in the bent shape. So if we look at the top view, the features that are in the top view, we want to try to establish what's dimensioned in the bent shape. So we have an 8mm hole and we have a pair of 3mm holes. So let's go ahead and let's put in the 8mm hole. We're going to achieve that by sketching on the flat plane, and we're going to draw ourselves a circle off to one end, and then we're going to draw ourselves a line that goes from the center edge of, we're going to go on the center edge of the top of the part down to the center of the bottom of the part. Okay, we're going to right click on that and make it a construction line, and we're going to make sure it's vertically constrained. I got an error because it already was. For posterity, I am going to take the top point and make it coincident with the top edge of the plane that we are working in. Okay, not sure why I got an error the first time. Now we're going to make the center of the circle coincident with that line, and we need a dimension from the center of that circle, and according to the print, it's the top of the ledge there, and it is 36mm. The only dimension we need now is we need to do the diameter, which is 8mm. We're going to select Finish Sketch, and we're going to do an extrude. We're going to select the center of the circle. We're going to change it to a cut. Rotate to a 3D view so you can see what's going on. And we're going to go, instead of going distance, we're going to go through all, and we need to flip the direction of the arrow to go through the part and select OK. So we have our 8mm hole now. Now we're going to put the two 3mm diameter holes up in this flange area. So to achieve that, we're going to make a sketch, and this time we're going to select on the plane that those holes are in. We'll go ahead and create a line. We're going to start off at the center of the top edge down to the center of the bottom of the part, or bottom of the bend. Okay, this is another construction line. We're going to right click on it and make it a hidden line. Double check that it's all constrained and nothing can move on it. We then are going to establish a couple points. So we're going to create a point. I'm going to put one on the left, one on the right. We're going to constrain those points to be horizontal to each other. And then we're going to dimension the distance between them as 36mm. And then the distance between one of them and our center line at 18mm, which is half of 36. It centers our pattern. And then we have a dimension from the top of the part to the edge of 5 millimeters. So that gives our hole location. This time around, I'm going to just go ahead and draw circles. We could use the hole command if you wanted. You'd have to exit the sketch. So I've drawn my 2 holes, hitting escape, and I'm going to make those 2 holes equal in size. Set up a relationship that they'll always be equal in diameter. And now I'm going to define the diameter on one of them as 3 millimeters. Okay, our sketch should be fully constrained, which it is. And we exited our sketch. And now we're going to do another extruded cut. We're going to select inside our 2 holes. We're going to switch again to through all, and we're not creating a new body, we're creating a cut, and we're going to flip the orientation of the arrow and hit OK. And we have our 2 holes. Alright, this is a good time to save. Now we're going to use the powerful part of the sheet metal function, because the rest of our dimensions to define this part are defined in the flat pattern mode in the drawing. So we want to define them the same way the drawing shows them. So we go to the modify command, and we're going to use the unfold command. Select unfold, and it asks you to select a stationary entity. Select the largest plane, and it will auto unfold the bends provided the checkbox is selected. You also have the option of individually selecting them, but if you've constructed your model correctly, it should be able to auto detect them. Select OK, and you now have the pattern in a flattened state. Now we're going to create a sketch in the plane of the part, the top of the part. And we're going to establish the tapered cuts on the sides. Now the drawing's ambiguous. It doesn't show a vertical dimension for the taper that hits this side wall, but it does appear to be in line with the center of the whole 8 millimeter hole we developed. So we're going to go ahead and make that assumption. So we're going to start with our line, and we're going to make it coincident with the edge, come up at an exaggerated angle, then try to go vertical, and then another angle to the right where it's going to touch the top. And I'll go a little bit past. And we're going to make sure that that end point is coincident with the top. Not perfect, but it's close. Now let's repeat that procedure on the opposite side. Go to the center, that'll get us approximately close to where we need to be. Click, vertical, and then an angle. That one picked up the auto angle for some reason, the other one didn't. Alright, next we're going to put in some constraints. We're going to constrain horizontally the endpoint, the center of our 8 millimeter circle, and the other side. So all of those are already set at their dimension and will stay horizontal at that location. Next, we're going to make the next angled points horizontally constrained, followed by the last ones. That way we only have to dimension one side, and those points will be constrained. Now let's enclose our shape so that we were sure we're going to be able to cut out the area we want to go away. So starting at the top point and then go to the corner of the model, and then we're going to go back to our starting point and draw another line enclosing the area we want to cut away. Repeat that procedure with the opposite side of the part. So before we put any dimensions on this part, we are going to establish a center line. That center line is going to be based off our 8mm circle because it's right in the middle. And we want to draw a line, and we want to make sure that that is vertically constrained, and we're going to convert it into a construction line. And let's go ahead and constrain it to the edge of the model with a coincident. We then can go from the dimension shown and put in a horizontal dimension that is half of the overall width of the dimensions between these two corners at the top. It says 43, so half of 43 would be 21.5. And then we can go from the one point to the other and put in 43. Our next dimension is going to be between one of the vertical lines and our center line, and we're going to call that one half of 45.5. Okay, which works out to 22.75. And now we can connect the dimension for the overall width between the two vertical lines, which should be 45.5. Now we've got all our horizontal dimensions in place. Now we need to put in the vertical dimensions. So we have a dimension from the top edge of our part to the first corner, and that is 15mm according to the drawing. Okay, so when we have our cutout sketches to the proper dimensions, we should have the top two narrowest points at 43mm, and then 45.5mm for the next segment, and then the last are at 50, and then 15 from the top with 5mm down, and then the bottom end point aligned with 8mm diameter hole. We should be able to go finish sketch at this point, and we're going to use an extruded cut, and we'll select the profile zones we want to go away, and the distance will be through all, and we're going to do a cut, and we need to flip the direction so that it's going through the part. We can then select OK, and we now have the angled cuts on the sides. The last features we put in the flat pattern is, first we need to put in a series of 3mm holes in the bottom flange. So we're going to create another sketch, and that sketch is going to be on the top of our part, and we'll go ahead and create 3 points. 1, 2, 3, and we're going to make those points horizontally constrained to each other. Dimension from one of the points to the edge of the part to give us our 3mm distance, and then from point to point is 20 millimeters. And we'll attempt to draw a line from the center to center. We'll set that at vertical and convert it into a construction line. And then we should be able to constrain it to the midpoint. Midpoint of the bend edge. So then we have our 3 points, and we can either use those points to make circles, or we can use the hole command. Either way. If we're going to draw circles in Extruded Cut, you're going to draw your 3 circles and constrain them to be equal. And then we just need to dimension one of them. Okay, finish sketch. We're going to do Extruded Cut. Change it to a cut. We select our profiles. We're going to go all the way through all and flip our direction. Okay, so we have our whole pattern in the bottom flange. Now the last feature to make is we have 3 millimeter corner fillet radiuses. So we can use the fillet command and go around and select our 3 corners. And we're going to make those 3 millimeters. Okay, we've pretty much modeled this part. Let's save it. And at this point, you can go refold faces. And we fold our part back and should have our end result matching what we want. Alright, we've now finished this part and we're at the end of the program for this one. And I hope you found this one helpful, and we'll catch you on the next one.